Now, just like we wanted subtraction to be able to undo addition, and we wanted division to be able to undo multiplication, we want to have a way to undo exponents. Now, this is a little bit more complicated because this operation we have with exponents is totally not commutative. So the role that the base plays and the role that the exponent plays are very, very different. As a simple example of how exponentiation is not commutative, notice that 3 squared, that's 3 times 3 is 9. On the other hand, 2 to the third, that's 2 times 2 times 2, is 8. And 8 and 9 are different. In fact, it turns out that the base and the exponent follow very different rules. Right now we're going to talk about a way to find out the base when you know the exponent. So we're going to talk about a way to find out answers to the two questions like, what number to the 4th power gives me 81? When I want to ask that question, the way that I write it is using this funky little squiggly sign. I put a 4 in the little hook here, and I write 81 inside. I read this as the 4th root of 81. And a little bit of trial and error tells me that, in fact, 3 to the 4th equals 81. And so the 4th root of 81 equals 3. These two statements describe the same fact. To say 3 to the 4th equals 81 means the same thing as to say the 4th root of 81 is 3. We like to ask this question in particular about second powers. So in particular, we like to ask the question, what to the 2nd power equals, for example, 49? Right. In that case, we just write the squiggle without a number. If we don't see a number written in, then invisibly it's a 2. Now, 7 to the 2nd power happens to be 49. And so we read this as the square root of 49 is 7. Right, so just as division looks for the missing thing in multiplication, one of these roots looks for the missing base of an exponent. Now, this symbol is called a radical. It may or may not have a number here. It does have a number inside. We're using it to compute a root, but the squiggly line itself is called a radical. Note the difference between a radical and the division bracket, which has just a curve here and not a hook up. Right, this number will be written in small, like an exponent. In the division bracket, this number would be written in full size. It's important to be aware that just as exponents are totally different from multiplication, radicals are totally different from division. Now, how do we actually compute these? Just like division, computing roots is a matter of trial and error. So, for example, if I asked you to find the square root of 225, well, you'd take a guess. The square root of 225 equals what? means what squared equals 225? Well, maybe you'd guess 10, right? 10 squared equals 100. Too small. Maybe next you'd guess 20. Well, 20 squared equals 2 times 2 is 4, followed by 2 zeros. That's too big. And then maybe you'd guess 15, because that's halfway in between. 15 squared? Well, that'll be, let's see, 15 times 15, 25, 5, 7, 5, 1, 5, 12, 2, 225. We've successfully guessed right. 15 squared is 225. So the square root of 225 equals 15. And that's it. It really is just a process of guessing. Now, that can get really tedious. So instead, we can compute roots on the calculator. And I'm going to show you several examples. The square root, let's say we want to compute the square root of 4096. Looking at the calculator, if we look closely at the x squared button, we see a little radical with no number right up above it. That's going to be our square root. So we'll hit second, and then the x squared button. I see we have a little square root with an open parenthesis. Type in everything that's inside the square root. Close the parenthesis, and we see that the square root of 4096 is 64. Not sure? Let's make sure. 64 to the second power really is 4096. Now, for other roots, let's say we want to take the fifth root of 1024. To enter that into the calculator, we need to go to the Math menu, right? Notice that option number 5 in the Math menu is a little radical with a little x inside it. That tells us we can make that any root. So I'm going to scroll down and select that. Uh-oh. Do you see it put in ANS here? It expected the little number to come first. So we have the little number, and then that x root thing, and then 1024. It says it's 4. That was weird. Let's make sure that worked. 4 to the fifth power really is 1024. To enter any root, not just the square root, first enter the number outside, which is called the index. Then choose the little x root from the Math menu, and then enter the number inside the radical.